All right, so let's work through this and see what we get. Okay, so it says 24.3 grams of aluminum chloride. That's how much aluminum chloride we want to produce. So that's this guy. And then I say, well, what mass of aluminum, remember mass means grams, of aluminum. Oh, so that's not the same substance, right? Aluminum is this substance right here. So I want to know what mass of aluminum is needed if I want to make this much aluminum chloride. It's kind of like saying this, hey, you want to make 6 batches of cookies, but this much only makes 1 batch. How much do I need of the oil if I want to make 6 batches? This is the same concept, except we're not making cookies, we're doing actual chemical reactions. So the first thing you do, so I have to travel. I'll call it the Stoichiometry train. So I got to travel on this train to go backwards from aluminum chloride to aluminum. If I want to make this much aluminum chloride, how much aluminum do I need? So like if I want to make this many cookies, how much of this ingredient must I have to make this many cookies? It's that same concept, but unfortunately we're not making cookies, we're making chemicals. Okay, so first thing you do is always write down what I gave you, 24.3 grams of aluminum chloride. And then to travel from aluminum chloride to aluminum on my Stoich train, the only way I can do that is by mole to mole ratios. And you have to be in moles. You can't be in any other unit except for moles to do mole to mole ratios. So right now, unfortunately, I'm not in moles. I'm in grams. So I have to turn grams into moles. So what unit goes on the bottom? Gram goes on the bottom and 1 mole goes on the top. The only way we can get from grams to moles or moles to grams is from molar mass. And molar mass is from the periodic table. So you take aluminum's molar mass and you add 3 of the chlorine's molar mass. Now, I did this for you up here, right? Aluminum is 26.98. Chlorine is 35.545 times 3. And that ends up being 106.4. You add those 2 numbers together and you get 133.4. So 133.4 grams per mole of aluminum chloride. Okay? So grams cancel. Now, we are at moles now. Yay! So now that I'm at moles of aluminum chloride, I can jump on my Stoich train and use mole to mole ratios to get from aluminum chloride over to aluminum. So who needs to go on the bottom? Well, the thing we don't want anymore goes on the bottom, and that's moles of aluminum chloride. The thing we do want, which is aluminum, goes on the top. So this is the mole to mole ratio. For every 2 moles, so I'll go up a little bit, of aluminum chloride that are produced, 2 moles of aluminum react. So yes, this is a 1-to-1 ratio, but that's okay. So now moles of aluminum chloride cancel. And now that we're at moles of aluminum, we can use molar mass to get us back to grams because it asked for mass. If this would have said what mole or how many moles of aluminum are needed, you would stop here. You'd be finished because you are at moles of aluminum, but they didn't. They asked for mass. So mole goes on the bottom, gram goes on the top. Grams per mole is molar mass, and molar mass is always per 1 mole. So this is for aluminum, right? So aluminum on the periodic table is 26.98 grams per 1 mole. So now moles of aluminum cancel, and we're left with grams of aluminum. So you do in your calculator, you do 24.3 divided by, because this is in the bottom, 133.4. You could pretty much skip this, but you can go ahead and multiply by 2 and divide by 2. It doesn't do anything to the number, right? This is a 1-to-1 ratio. And then you multiply by 26.98. And based on a bunch of my chats, it sounds like a lot of us got this, 4.91 grams of aluminum. So you must put the unit of grams and you must put the substance of aluminum. and it's 3 sig figs because this is 3 sig figs. So what that means is if I want to make 24.3 grams of aluminum chloride, I need to have at least 4.91 grams of aluminum to be able to do this. So again, grams to moles, so I'll repeat this. Oops, whoa. Eek. Stop. Okay. Grams to moles or moles to grams happens from the periodic table. Molar mass. Molar mass. I'll do some substance A. Mole to mole ratios is stoichiometry. This is the definition of what stoichiometry is. This is the balanced reaction. These are your coefficients. And then you can get from moles back to grams by using the periodic table, molar mass. So this right here is the new part. The mole to mole is the new part. This is the stoichiometry part, mole to mole ratios. The grams to moles is stuff we learned prior. That's prior knowledge. We have converted grams to moles. We used to do grams to moles and moles to like atoms or molecules. Now what we're doing is we're taking grams of one substance and trying to figure out information about a separate substance in a chemical reaction. So again, this mole to mole ratio is your stoichiometry. Now, be very careful when reading the problem. You don't always go from grams to grams. You need to really read. Like I said, if this would have said moles, you would have done grams to moles, and then you would have done moles to moles, and this would not have been necessary. So you need to make sure you stop where it asks you to stop. Because if it says moles, you don't go to grams, you only go to moles. So just make sure you read the problems really carefully.